Last lecture, we completed the vertical plane surfaces. In this lecture, we'll understand for horizontal plane surface. So for vertical plane surface, Fp, that is the pressure force, that is equal to omega x bar into area. And now we'll see the horizontal plane surface. So theta, that is equal to 180 degree or 0 degree. Now consider this is the free surface here. This is the free surface, and there is any plane, there is any plate is there, and the plate is from the free surface, the distance is x bar, that is equal to h bar. So g is the center of gravity and cp is the center of pressure. So here the center of pressure and center of gravity coincide in each other for horizontal plane surfaces. So if you want to calculate pressure, that is equal to rho into g into x bar is the height from the free surface to the center of gravity. Now if you want to calculate the pressure force, Fp, that is pressure into area. So pressure, that is equal to rho g x bar into area. So from here, Fp, that is equal to omega into x bar into area. X bar is the distance from this here, this to this, and omega, that is equal to rho into g, and A is the area of the plate. And here h bar, that is equal to x bar. So this is all about the horizontal plane surface. So for vertical plane surface, the Fp was omega x bar into area, and for horizontal plane surface, that is Fp, that is equal to omega x bar into area, the same formula. Now we'll understand the inclined plane surface. Now for inclined plane surface, so this is, suppose this is the free surface here, this is the free surface, and this is the rigid wall. Here to here, this is the rigid wall, and here to here, this is the rigid wall, and here from A to B there is a plate. Okay, and here this is the angle, theta is the angle from the free surface. So this is the plate angle, theta, from the free surface. Now if this is theta, this will be theta, and this angle will be 180 degree minus theta. So g is the center of gravity. So the height from the free surface to center of gravity, that is x bar. The height from the free surface to the center of pressure, that is h bar. And the pressure force which is acting on the center of pressure, the total pressure force which is acting on the center of pressure. Now this plate, it may be a rectangle, it may be a triangle, or it may be circle. So area may be different area. Maybe it is a rectangle, triangle, or another shapes. Now for inclined surface, the Fp, that is pressure force, omega A into x bar. Same formula, same as vertical or horizontal plane surface. Now if you want to calculate the relation between h bar and x bar, so h bar, that is equal to Igg into sine square theta by ax bar plus x bar. So Igg, this is the center of, so Igg is the moment of inertia about center of gravity, theta is the angle, and A is the area of the plate, and x bar is the distance from the free surface to the center of gravity. Okay, and plus x bar. So remember this formula. Now we'll understand the plane surface. This is the column for plane surface, and this is the column for center of gravity from the base. This is the column for area. So what is the area? This is the column for moment of inertia about an axis passing through the center of gravity and parallel to the base. So Igg, if you want to calculate the Igg, so this is the column for Igg, and this is the column for moment of inertia about the base I0. So this is the case. Now first, this is the rectangle. Here the rectangular plate have length b and width, that is h, width or height, that is h. So g is the center of gravity here. G is the center of gravity. Now cg from the base. So cg from the base, center of gravity from the base, that is the here to here, this is x. So x equal to d, total distance, total height, divided by 2. Now if you want to calculate the area, that is b into d. If you want to calculate the area, that is this distance into this distance. This is the area. Now if you want to calculate the Igg, that is equal to b d cube divided by 12. So Igg for rectangle, that is b d cube divided by 12. Now I0, that is b d cube divided by 3. So this is all about the rectangle. Now if you focus on the triangle, for triangle, the length of the triangle, that is b, that is the base, and the height, that is h, g is the center of gravity, and the cg from the base, center of gravity from the base, what is the distance? So this is the distance. So from here to here, this is x. So this x will be h by 3. So total height h divided by 3. And what is the area? That is b into h by 2. We know that. And what is the Igg value? That is b h cube by 36. And what is I0? That is b h cube divided by 12. Okay. For circle, so this is for circle. So the diameter of the circle, that is d, and g is the center of gravity here. So from the base to the center of gravity, the distance is x. And if you want to calculate the value of x equal to d by 2, what is the area? That is pi by 4 d square, we know that. And what is the value of Igg? That is pi d to the power 4 upon 64. Remember, this is very important for the circle. For trapezium, so this is the base for trapezium, that is b, and here there is a distance, that is a, and the height between two parallel lines, that is h, and this is the gravitational acceleration. So from the base to the distance from the base to the gravitational acceleration, x, that is equal to 2a plus b by a plus b into h by 3. So this is, remember this data. And what is the area? That is the standard formula, A plus B divided by 2 into H. Okay, and what is the value of IgG? That is A square plus 4AB plus B square divided by 36 into A plus B into H cube. Okay, and for a semicircle, so consider this is for semicircle and this is the center of gravity for the semicircle, and this is the radius r, here is the radius r. Okay, now if you want to calculate from the base to the high g distance, x that is equal to 4r by 3 pi, remember this data very important. And if you want to calculate the area, standard formula, that is pi r square by 2, and if you want to calculate the IgG, that is equal to 0.1 into r to the power 4. Okay, remember this data. Now the focus on the, suppose there is a rigid wall, here to here this is a rigid wall, and here to here there is any plate, and after that there is a rigid wall. So there is a fluid, the left side there is a fluid are there. So from A to B, it may be any plate, it may be a rectangular plate, it may be triangular plate, it may be circular plate, it may be semicircular plate, it may be trapezium plate. So here G is the center of gravity of this plate. So from free surface to center of gravity G, the distance is x bar, and from the free surface to center of pressure, the distance is h bar. Okay, and the red color, this is the atmospheric pressure, and this is the pressure change with respect to depth. Okay, now let's understand one important question. So a triangular gate with a base width of 2 meter and a height of 1.5 meter lies in a vertical plane. The top vertex of the gate is 1.5 meter below the surface of a tank which contain oil of specific gravity 0.8. Considering the density of water and gravitational acceleration, so acceleration due to gravity, to be 1000 kg per meter cube and 9.81 meter per second square respectively. The hydrostatic force in kilonewton exerted by the oil on the gate edge. So you have to find out the hydrostatic force F. So what is given in this question? So there is an oil tank. The density of the oil, that is specific gravity, is given, that is 0.8. So what is the density? That is 800. So density of water which is given in this question, that is 1000 kg per meter cube. Oil density, that specific gravity is given. So oil density will be 1000 into 0.8, that is equal to 800 kg per meter cube. G is the gravitational acceleration that is given in this question, that is 9.81 meter per second square. So now focus on this, what is given in this question. So here there is a oil tank, and A to B there is a plate, and this plate is triangular plate. So A to B. Okay, now here this point to this point the height is given, that is 1.5 meter, and consider there is a G, center of gravity, and this is the center of pressure. So from the free surface to the center of gravity, the distance is x bar, and from the free surface to the center of pressure, the distance is h bar. Okay, now the height of the triangle that is given, that is 1.5 meter. Okay, and the base, that is 2 meter, which is given in this question. Now if you want to calculate the x bar, if you want to calculate this x bar will be 1.5, this x bar will be 1.5 plus this distance. What will be this distance? That will be 2 by 3 into 1.5. 2 by 3 into 1.5. So here to here the distance will be 1 by 3 into h. Okay, and here that 2 by 3 into h. So 2 by 3 into 1.5. So that will be equal to 1.5 plus 1. So that is equal to 2 meter. Now if you want to calculate the pressure force, we know that for pressure force, omega into A into x bar, omega that is equal to rho g into A into x bar, that is equal to rho is the density of oil, that is 8, g is the gravitational acceleration 9.81, into area, that is half, into 2 into height, that is 1.5, into x bar, that is 2.5 Newton. So from here if you calculate this value, that will be equal to 29.43 kilonewton. So this will be our answer. Now in question, if asked in that way, what is the force required when the door is not open? So what is the value of force if the door is not open? So how to calculate this? So h bar, we know that IgG by a x bar square, IgG sin square theta divided by a x bar plus x bar. So just put the value IgG for triangle, we know that b d cube by 12, 36. So 2 into 1.5 to the power cube divided by 36. So 36 divided by area 1 by 2 into 1.5 into 2.5 plus x bar, that is given in this question 2.5. So from here it will be 2.5 meter. Okay, and theta here, the theta is 90 degrees. So sin theta, that is equal to 1. So sin square theta, that is equal to 1. Okay, now if you want to calculate the value of AC, so just here the AB, so here the same plate AB. So if you want to calculate the value of AC, so how to calculate this value of AC? So h bar which is given, so here to here the distance is h bar, that is 2.5. So this distance is 2.5. So 2.5 minus 1.5 is what? This is distance. So minus of 1.5, this distance. So 2.5 minus 1.5, that is equal to 1.05 meter. Now if you take the moment about A, that is equal to 0. So from here Fp, that is the pressure force, into this distance, that is a perpendicular distance 1.05. This is, so here there is a moment about A. So there is a anti-clockwise means minus, anti-clockwise plus. So Fp into 1.05, and here the pressure force, there is a force which is acting at point B. So this is clockwise moment. So minus of F into 1.5 is the distance from A to B. So from here if you calculate this value, F will be 20.6 kilonewton. So this is the answer. If the door is not open, the force required. So this is my handwritten notes. You can download it from the description. The PDF format available in the description. Like, share and subscribe my YouTube channel. Thank you.